Bismillahirrahmanirrahim. Electrical network analysis, and today our topic is Fourier series. So, in the previous lecture, we have taught about the even and odd and the formula for the coefficients of the Fourier series, and the sine terms and the cosine terms and the DC terms. So now, in this lecture, we have to apply these formulas on different functions. So let's start with the square function. Here is a square function. Okay, so you can see from 0 to 1 its magnitude is plus 4, and from 1 to 2 its magnitude is minus 4. Okay, so we have to find a naught, a n, and bn. Okay, so a naught is the DC term, a n and a n are the magnitude of the sine terms, and bn the magnitude of the cosine term. So first of all, we have to write the function f of t is equal to, from 0 to 1 it's 4, and from 1 to 2 it's minus 4. Okay, so f of t is this, and as we can see, for the cycle the period is 2. Okay, so now a naught is equal to 1 over t, 0 to t, f of t dt. That's the formula for the a naught. A naught is the coefficient of the DC term. Okay, so t is 2, the time period. Okay, and have already discussed in the previous class that Fourier series is only applicable to the periodic functions. Okay, so it's a periodic function which repeats itself after equal interval of time. So 1 over 2, 0 to, from 0 to 1. Okay, there are two portions of the function. So from 0 to 1, we have to split uh, accordingly. Okay, so from 0 to 1 it's 4 dt, plus from 1 to 2 it's minus 4. uh, After the integration, okay, so we will get 40, 0 to 1 minus 40, 1 to 2. Okay, so now putting the limits, 1 minus 0 and 2 minus 1. So as I have already discussed in the previous lecture, that if we have the area under the curve for the positive and the negative term are equal, then a naught will be 0. Okay, so that's the proof a naught is equal to 0. Okay, now uh, an an is equal to 2 by t, 0 to t, f of t sine omega t. Okay, putting the values, 0, 2 by 2, 0 to 1, 4. Okay, and 4 sine n omega t, it's n omega t. Okay, n omega t, n omega t. Okay, and from 1 to 2 minus 4 sine n omega t. Okay, so applying the integration of sine is minus cosine n omega t divided by n omega. Okay, and minus 4 sine n omega t. So minus will be, after applying, we will get minus 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 plus 4 cos n omega t over n omega. Okay, so putting the values. Okay, okay, now for the omega, as we know that omega is equal to 2 pi f, and f is equal to 1 over t. Okay, so and we have known that the t is equal to 2, so omega will be equal to 2 pi over 2. 2 will be cancelled out, so we will get omega is equal to pi. Okay, so putting the values, 1 over n omega, so 1 over n pi minus 4 cos n pi plus 4t, 4 2 n pi minus 4 n pi. Okay, so now we have to see that what will be the value for cos n pi and cos 2 n pi. Okay, cos 2 n pi, where n is the integer from okay, any integer, 0 plus minus 1 plus minus 2, okay, and so on. So now for cos n omega t, if n is equal to any odd number, Let's start with the even first. Okay, so even number means, for example, n is equal to 0. So put n is equal to 0, cos 0 into pi. Okay, 0 into pi, angle will be 0, so cos 0 is equal to 1. Similarly, if you put n is equal to 2, so cos 2 and 2 pi is equal to 1. Same. Okay, now if we have n is equal to uh, odd. Okay, for example, n is equal to 1, so then in that case cos 1 pi, 1 into pi means pi, cos cos 1 pi is equal to minus 1, so it means cos n pi is different for n even and n odd. For n even it's 1, and for n odd it's minus 1. Okay, now cos 2 n pi, cos 2 n pi, for example, n is equal to 0 means we are assuming the even numbers. Okay, so 2 into 0 into pi, cos 0. Okay, cos 0 will be equal to 1. Okay, now if n is equal to 1, so cos 2 into 1 into pi means cos 2 pi. Okay, so cos 2 pi is equal to, again cos 2 pi is equal to 1. So it means cos n pi is equal to 1 for any, for all n. Okay, but this is not the case for cos n pi. Okay, so for cos n pi, n is equal to for cos n pi is equal to 1 for even, and cos n pi is equal to minus 1 for odd. Okay, so now bn. Okay, bn 2 by t 0 to t f of t cos and omega t. Okay, now bn is the coefficient of the cosine term. Okay, so putting the values, okay, from 0 to 1 4 minus, from 1 to 2 minus 4. Okay, so now cos pi. Okay, and cos pi is cos omega is pi, so sine 2n pi and sine n pi, we get sin n pi and sin 2n pi. So in either case, if n is equal to 0 or n is equal to 1, in either case sin sin pi is 0, sin pi is equal to 0, sin pi is equal to 0 for all number of n, whether it is even or odd. Okay, and same is the case with the sin 2n pi. Sin 2n pi is equal to 0 for all n. Okay, so bn is equal to 0. So as a naught is equal to 0, b naught is equal to 0, and a n is non-zero, means having some value, so the function is odd. And we can also mm, knew it in advance because it's an odd function. Okay, so now move on to the next function. These are a few standard functions. Okay, the ramp function. Okay, negative slope function, positive plus negative slope function, exponentially rising function, sinusoidal function. Okay, cosine function. Okay, so now the second function is even function. From minus 1 to 1, its value is 3. Okay, so f of t is equal to 3 from minus 1 to 1, and this is also the part of the cycle. Okay, this 0 portion. So 1 to 2, it is equal to 0, so the time period is from minus 1 to 2, it is equal to 3. 1 2 3. Okay, a naught 1 over t, 0 to 1 f of t. Okay, now 0 to t, 0 to t, so t is equal to, from minus 1 to 1, its value is 3, and from 1 to 2, its value is 0. Okay, so applying the integration, putting the values, we will get a naught is equal to 2. Now the area under the curve for the positive and the negative portion are not equal, so you will have some value for the a naught. Okay, now an is equal to 2 by t 0 to t f of t sin n omega t. Okay, putting the values of the function from minus 1 to 1 sin n omega 3 sin n omega t, from 1 to 2 0. Okay, so putting the values, applying the integration, putting the limits, but before, mm, okay, now we have to find omega. Omega here, omega is equal to 2 pi over 2. Okay, actually omega is 2 pi f and f is equal to 1 over t, so omega is equal to 2 pi by t. T is 3, so 2 pi by 3. And for all values of cos n, 2 pi by 3, and cos 2n, okay, cos n 2n pi by 3, the value of this is equal to 0, so an is equal to 0. Now bn, okay, so bn is again 0. Okay, after all the process, so it means we have only a dc term, we don't have any sine or cosine term. Okay. Now the ramp function. Okay, so in this case we have to apply the 2-point formula. We have already discussed the 2-point formula in the previous class. Okay, so now just applying it, so we will get f of t is equal to 2t. Okay, so a naught will be equal to 1, and an, for an we have to apply uh, integration by parts. Okay, 1 and 2. So 1 into integration of second minus integral differential of first integration of second. Okay, so after putting the values we will get this. Okay, so now we have to apply omega, we have to find omega. Omega is equal to 2 pi by t, 2 pi by 1, the time period is 1. Okay, from 0 to 1 it's 1. This is a constant line. Okay, not the negative slope. So time period is how much? Time period is 1. Okay, so 2 pi by 1, omega is equal to 2 pi, putting the values cos 2n pi and sin 2n pi. So cos 2n pi is minus 1 for all the values of n, and sin 2n pi is equal to 0. So we can write the final answer in this case if we have uh, the same value for n is equal to odd and n is equal to even. Okay, so as for n is equal to odd and for n is equal to even, the cos 2 and pi is the same, so we can finalize the answer by putting the values, by putting the answer is equal to minus 1. Okay, and for any value of n, whether it is even or odd, sine 2 and pi is equal to 0 in either, in any case. So we can finalize the answer by putting the value is equal to 0. Okay, so now multiplying we will get bn is equal to minus 2 over n pi. Okay, so that was all about the Fourier. uh, for the practice, you can apply the Fourier series for example, this is a function. Okay, so for example it is the value is 2 over here, this is 0, this is 1, and this is 2. Okay, so what do you have to do? So you have to apply Fourier series, and now in this case function has two portions. The one is from 0 to 1 and the other is from 1 to 2. Okay, so you have to apply the 2-point formula in both of these cases, and you can see that in this case the slope is positive and in this case the slope is negative. Okay, the initial values are 0 for x and for y it is also 0, and the final values Okay, x2 y2, x2 is 1, okay, and y2 is 2. Now this final parts x2 and y2 are the initial value for this slope. Okay, now that will be x1 and y1 for the second portion of the function. Okay, so and for and then here we will have x2 and y2, which will be 2, x is 2 and y is equal to 0. So applying x minus x1 divided by x2 minus x1, okay, is equal to y minus y1, y minus y1 divided by y2 minus y1, y minus y1 divided by y2 minus y1. Here y is the function f of t, okay, and the x is equal to t. Okay, so putting the values you will get the answer for this, and then applying the same formula for this as well. So we will have function values in two portion, one from 0 to 1 and other is from 1 to 2, and the time period of the whole function will be 2. Okay, so it's a homework for you people. That was all about the Fourier series. So in the second portion of the lecture, we will discuss the Laplace transform. It's a new chapter, so we will discuss it in the next class. Okay, thank you.